My name's Jason Partica here at Delfield, and we're going to go through our R290 training. We've been using R290 for a number of years here now in the States, for about the last 5 years or so. In Europe, they've been using it pretty much when we went from 404 to, or from 22 to 404 rather, here in the States. That's about the time Europe started going to R290. They've been using it in coolers and freezers, household ones, commercial ones there for a number of years. It's safe, it's efficient. There's no ozone depletion properties. It's an alternative for some most commonly used refrigerants. It's not a direct drop-in, so you can't take an old R12 unit and throw some 290 in it. We use it in everything we build essentially here. Low temp, medium temp, high temp applications. I mentioned the ozone depletion properties there. It is flammable. R290 is a 99.5% pure propane, so it's going to definitely have some flammability to it there. You'll notice the yellow stickers on a lot of our equipment. With R290, you'll see these stickers pretty much everywhere on it. R290 also, it's odorless, so you're not going to have a smell. You're not going to smell gas. It's not like your backyard barbecue, the propane tank on that, where it's about 95% pure propane. They add that rotten egg smell, so you can tell if you got a leak going on there or something. As far as the refrigeration system, really no big difference here between what you'll see on a 404 system. We'll use expansion valves, we use cap tubes, depending on the application. It's about 50-50 on that. But the only difference obviously being the type of refrigerant in the system. As far as our components that we use, compressors, they're going to have internal protection to prevent sparking. Filter dryers, essentially any filter dryer would work on these systems. However, due to the limited refrigerant capacity, we recommend using a Delfield OEM filter dryer for any repair that you do. So if you need to replace a TXV and you're putting in a new dryer as well, make sure you're using an OEM filter dryer. As far as the refrigerant capacity, as I mentioned, it's a bit limited due to the R290. We can only put about 5.5 ounces per system in. So we had to use a smaller filter dryer to kind of accommodate that as well. So we want to make sure that when we're replacing our parts, we're going back with the OEM ones. As far as a metering device, like I said, we use cap tubes, we use TXVs. There's no that's about a 50-50 split as far as when we're using those. Evaporator coils, they're going to be sized for an R290 system. A lot of our line sizing has changed as well, again, due to the limited capacity. In the past, where we may have used 3/8 and 1/4 inch, you may be seeing 5/16 and 3/16 on the line sizing now. So it's possible there's some difference there with the size of the coils on those. As far as ignition sources, so I'm sure we've all started a few fires in our days. Sparks, obviously a big one, so we want to make sure that our electrical connections are tight. There's no loose connections, no loose wires. Make sure the wires are insulated so there isn't any chance of a spark causing a short, which could cause ignition of R290 if there's a leak. Open flames is something we want to make sure that we're aware of with these as well. We do build units that are a low boy cooler with like a grill or a char broiler on top that may have a standing pilot. We had to send the equipment when we first tested it to UL to simulate a catastrophic failure. And what they did was that we manufactured a unit that had valves or fittings on them so they could be quickly removed so all the gas could escape from the system. It passed all the UL testing. If it hadn't, we wouldn't be able to sell the equipment in the U.S. or anywhere for that matter. So that's something where where you're going to see that on some of these units as well. We want to make sure there's air gaps if possible, and it's well ventilated. I know where some of these units are located at, they get into some places where it's a little tight, not a whole lot of room. But if we have the ability to move those units to a location where we can to work on them where it's a little bit more open, that would definitely help. As far as um, hot surfaces, so the magic number here is 842 degrees. We'd have to have a lot happening to have ignition with a hot surface. So you'd have to have a unit that has a leak. We have to have an 842 degree surface temperature, and then we have to have the right air and propane mixture on that as well. So we got to have a lot of different factors going on here to have ignition based off just a hot surface temperature. Just some general safety tips when working with R290. We want to make sure you're not working within confined spaces. Again, some of those units are going to be in some pretty tight spots, so if we can move them to a back room, take them outside, depending on the time of year it is. Flammable materials, we don't want to have anything like that around when working with an R290 system. Ignition sources, same thing. I'm not too worried about that small amount of gas in the system possibly igniting, but if there's a stack of cardboard boxes or pallets or whatever they may have around that could catch fire, those type of things could quickly spread and cause a major issue. Fire extinguishers, if you're not using them already, you're going to want to consider having them nearby when working with an R290 system. And we had talked earlier about ventilation. You want to make sure wherever you're working at, make sure the area is properly ventilated. So before working on the electrical system, we want to make sure the unit's grounded and that ground doesn't break. We want to make sure capacitors are discharged. We want to make sure we're being careful and working with live electrical components. Again, just for the chance that we could have a wire arcing or something that could cause ignition. And then as far as any of our components on the systems, like a capacitor or relay, our temperature controls, a lot of those are made with plastic, and if the housings on those are cracked or broken, you're just going to want to replace those. Even if the unit's working fine, we'll want to replace those components with OEM components on there. Some suggested tools that we have. Again, these aren't necessarily required, but they're kind of some nice to haves here for these is a tool that measures the line temp as opposed to putting on gauges and trying to get pressures. Stubby gauges, short hoses, those are all nice things to have when working on these because again, our very limited charge amount makes things difficult, especially if you tap the system and try to get an accurate pressure reading. The next three slides I'm going to show you here are some line temperatures. This was on an under-counter cooler, so just kind of some things to keep in mind for line temps. It'll be at a 75, an 86, and 100 degree ambient temperatures. And if you pay attention to the little to the temperature numbers inside the little yellow boxes there, you can kind of see the differences as our ambient temperature starts to rise. So we'll start out here at 75. You'll notice the inlet and outlet temperatures of the evaporator and the condenser there, compressor top and bottom, as well as the suction line temperature. As we take that up to 86 degrees, you'll notice that especially take a close look at that compressor top and bottom, how that starts to heat up quite a bit more. The inlet of that condenser coil is getting a bit hotter. And then we take that all the way up to 100 degrees, and we got quite a difference there with that. The compressor and the condenser outlet, those seem to get quite a bit warmer on that, and then there's just a slight rise on some of the other components there. So instead of checking pressures, tapping the system, if you have some thermocouples or some clamp-on style type of devices to record line temp, you can use those to get some line temps to translate to a pressure to hopefully diagnose what your issue could be. Also, amp draw on the compressor is a good one to check as well. If we have a low amp draw, that's pretty indicative of a low charge in a system. As far as some service procedures, we do have a note on here about before you tap into the system, if it's possible to run the compressor a bit before changing any components there. That'll help separate the refrigerant from the oil in there. Obviously, if you got a bad compressor, you're probably not going to be able to do that. But just a note that if you run into that situation, you can go ahead and run that compressor if possible. That'll help you there. We want to make sure we're using piercing valves to access the system. We don't want to leave any sort of piercing valves or any sort of Schrader or access fittings on the system when we're done. We want to make sure that the system is completely sealed. As far as accessing the system, there really isn't any difference with accessing the system as what you're used to doing today with any other sort of sealed system. So there isn't really a big change on that. There may be some instances where you can't vent R290, because normally you should be able to vent it. You may run into some instances, whether it's at an airport or a hospital or a school or somewhere where they may have some more stringent guidelines as far as that goes. But under normal conditions, you can vent R290, but you may have to do what's called a passive recovery. Essentially, what a passive recovery is, you're going to take a small cylinder, you'll run it into a vacuum, and then you'll put your piercing valve on the system, and then you'll put one end of the hose on the refrigeration system, the other end on your cylinder. You open up that cylinder, and that vacuum from the cylinder will suck out the refrigerant on there, and then you'll have a little bit of R290 to vent elsewhere. As far as leak detection goes, soap bubbles is our tried and true procedure on that. As far as that goes, we recommend pressurizing the system, 250 to 300 pounds of nitrogen. Take the soap bubbles out and see if we can identify a leak that way. You see the service bulletin here. We no longer recommended using the combustion gas leak detectors just because we found that the sensitivity on those tends to wear after a while. The best course of action for leaks is pressurize the system with the 250 to 300 pounds of nitrogen, and then add in maybe just a trace amount of 404 or 134, and then using just a regular fluorocarbon leak detector to try and identify the leaks. Components should never be removed with a torch. We always recommend using a tubing cutter of some sort. The next slide shows kind of what happens if you decide to go in with a torch to try and unsweat some components. Had an overzealous tech here who tried to unsweat some components, and you'll notice the inside of the unit got nice and crispy on us. Got some melting plastic there. So please do not use a torch to remove components from the system. Always use a tubing cutter. We recommend purging the system with nitrogen a couple of times. Just helps make sure that everything is clear in the system there, no refrigerant left over. We ask that you braze whenever possible. So when you're putting in that new compressor, putting in the new TXV, whatever it is, we do recommend brazing. We do have a couple of other methods that we do approve. LOKRINGs, which is a German manufacturer. The LOKRING tool, they have their own fittings for those. And then Zoom lock fittings, those are also approved by Delfield as well. So what we don't want you using is any sort of like a mechanical type fitting to seal a system on that. But we need to make sure that, again, as I mentioned before, the unit, there's no Schrader valves or piercing valves left on the system. We want to make sure that we take those off after we complete our repair. So we're going to do our evacuation of the system. We talked about using the tubing cutters there to remove components. Really, the same rules apply as far as um, vacuum procedures on that. We're looking for a 500 micron vacuum, and we'd like to have that hold for at least 20 minutes with the pump off. So turn your pump off, turn your gauge off, let it sit. Should hold for a good 20 minutes there, at least at 500, before we proceed on that. We want to make sure the unit's grounded, so we mentioned that before as well. Charging the R290 system, it's pretty similar to charging if it were 404 or 134 or any other refrigerant. We normally recommend charging it as a liquid as opposed to a vapor, just for the sake of time more than anything. It can be charged either way, but we recommend charging it as a liquid. As far as charging the system, very, very critical not to overfill it. The charge amounts are typically about half of what you'd see from like a 404 system that we'd have built a few years back. So you want to make sure your scales are calibrated properly, and that they also read in grams and ounces. Some of our data tags have grams, some have ounces. So most of them have that conversion on it. So you should be able to use either one there. As far as pressures go, this is just an example of a freezer and a cooler. 85 degree ambient, one's at 40, the refrigerator, the freezer's at 0. You see our standing pressure is typically going to be about 135 or so, and then the head pressure at 85 degrees is typically going to put you about 215, and then you see the different pressures there from 40 degrees to 33 on the cooler, and then from 0 down to -5. An alternative to brazing, we mentioned the LOKRING tool earlier. That was something before that we were really pushing when we first introduced R290, because as far as sealing the system up. So as far as LOKRING goes, the tool, you'll see it there in the top right. It's got like a ratcheting style handles on it. And then the next few pictures here just kind of show looks like a compressor replacement. They'll clean that area with some little sandpaper on that, and then they're going to put the LOKRING fitting on. You'll notice the blue bottle there. That's like a line prep. And you'll just take that. You put like a little dot on the line, and then take that fitting and work it around there. You'll push that connector onto the tubing as far as you can push it at that time, and then the LOKRING tool, you'll open that up, and that ratcheting handle, you'll see what it leads you to there at the bottom. So once you can't move it anymore, that's pretty much it. So you'll know when it's all the way in. So and the LOKRING tool has different size heads on it. The heads are replaceable. So if you're working on a 3/8 line, then go to a 5/16 or a quarter inch, whatever it may be. Those heads are replaceable, so you can use those for different size lines, and then there's different size fittings as well.